So in this lecture we will be proving the Cauchy Schwarz inequality, and we will prove that the equality of the equality holds when the variables are proportional to each other. So let's first write the Cauchy Schwarz inequality, which says that for any two variables ai and bi, summation I is equal to 1 to n ai square into summation I is equal to 1 to n bi square is always greater than equal to summation ai bi, I varies from 1 to n whole square. So let's get into the proof. So first we take a positive constant lambda is equal to a positive constant. So we can always say that summation of a square quantity is always greater than equal to 0, whatever be the variable inside, as long as they are all real. Okay, no imaginary things in the picture. So let's write summation I is equal to 1 to n lambda ai plus bi whole square is always greater than equal to 0. At max this can be equal to 0, but let's just say it's greater than equal to 0. Now let's break the whole thing. It becomes lambda square into summation ai square. I am not writing the I is equal to 1 to n part, but it is there. So ai square plus 2 lambda summation ai bi plus summation bi square greater than equal to 0. So I am writing this part. I'll denote it with a different color. This part I am writing as A, this part I am writing as B, and this part I am writing as C. So the whole equation becomes A lambda square plus 2 lambda B plus C greater than equal to 0. So we can rearrange the equation, that is we divide the whole thing with A so that the coefficient of lambda square becomes 1. So dividing A throughout, we get lambda square plus 2 into B by A lambda plus C by A greater than equal to 0. So now we manipulate the following things and we get lambda plus B by A whole square plus C by A minus B square by A square greater than equal to 0. I am just rearranging the terms. In this line, just adding plus B square by A square and minus B square by A square. So the B square by A square term is clubbed into this, and the minus part is coming here. So that's only the thing that I am doing, nothing to be confused here. So now it becomes lambda plus B by A whole square plus AC minus B square by A square greater than equal to 0. Now this part is already a square quantity which is greater than equal to 0. So for the whole thing to be greater than equal to 0 for any real lambda, this part also has to be greater than equal to 0. So we write it, I am writing it in a different color from now on, that AC minus B square by A square greater than equal to 0. Now A square is always greater than equal to 0 for any value. So to maintain this inequality, AC minus B square also has to be greater than equal to 0, which means that AC is greater than equal to B square. Now if we substitute the consequent values, it becomes A is summation ai square, C is summation bi square, and B is summation ai bi, and it is a whole square, so whole square. All I is equal to 1 to n, all varies from I is equal to 1 to n, I is equal to 1 to n. So the first part is proved. Now let's go to the second part, that is the equality part. If we write A AI and BI are proportional implies AI by BI is equal to a constant. So we denote it with K. So AI is equal to K into BI. Now to prove the equality, let's go for the LHS and RHS approach. So the LHS becomes summation AI square into summation BI square is equal to, now I write AI as K times BI, so it becomes summation K square BI square into summation BI square. Now I can bring out the K square terms because it is independent of there is no I in it, so it can be taken out of the summation. So it becomes K square into summation BI square into summation BI square, that is K times summation BI square whole square. This is what it ultimately becomes. Now let's see the RHS part. I am doing it in a different color. RHS part says it is summation AI BI whole square. So the AI becomes it is nothing but K times BI, summation K times BI into BI. So what it becomes, I can take the K out of the summation because it is independent of I. So K times summation BI square, and there is a whole square here, I missed it, whole square. So we can see that these two are the same, so hence the equality is also proved. Thank you for watching the video. Do share and subscribe and like the video because it really motivates me in growing the channel. Thank you.